everyone. Welcome back to the Professor Moose Learning Center. You know, this place, the Moose Laboratories. Today we're gonna be learning what an iconic and a molecular compound is. Now they may sound confusing, but really, if you pay attention here, they aren't that actually confusing. Anyways, without further ado, let's get on to the video and let's start learning. And hello! Welcome. We're now in the basement, just looking at all of our good old elements. Now, just take a quick look here. Got all these, isn't that cool? All this stuff, look at all that. Okay, but our main topic here is, if you remember from the start, is iconic versus molecular. Isn't that cool? Now, if we take a quick look here at what an iconic versus molecular is inside of our books here. If we take a little flippy flip into the book here, we can see that if we go up and up, we'll see ionic compounds. I was saying that wrong the whole time. But anyways, most people are familiar with common table salt and know that it is this white substance composed of tiny crystals. You might be surprised to learn that table salt is formed when a very reactive metal, sodium, is placed in a container with a poisonous green non-metal chlorine gas. When the two chemical elements are combined, the sodium metal explodes in a bright yellow flame. As the sodium burns, a white coarse-grained powder is produced. The powder is table salt, or as you know, sodium chloride. Sodium chloride is called an ionic compound. Ionic compounds are pure substances formed as a result of the attraction between particles of opposite charges, called ions. Table salt is formed from positively charged sodium ions and negatively charged chloride ions. Other properties of ionic compounds include their high melting point, good electrical conductivity, and distinct crystal shape. All ionic compounds are solid at a room's temperature. In fact, table salt will not melt until it's heated to 801 degrees Celsius. When an ionic compound is melted or dissolved in the water, it'll conduct electricity. This property of ionic compounds led to the study of electrochemical cells that either convert chemical energy into the electrical energy or electrical energy into chemical energy. That works eventually. Okay? So, right here, it says sodium and chlorine gas. And you wouldn't be surprised, but if we take a little looky inside of our chest here, we have chlorine. So we're wondering, what are we going to do with chlorine? If I knew how to work these, I'd probably be able to do this. But we make chlorine gas, see? But we also need sodium now. So if we try to find our sodium here. Well, 1 second. There we go. Sodium. So, we take our sodium here and our chlorine. Let's go into our testing chamber. Which one? Not the dangerous one. Look, Bob's here. Bob's ready to watch. Bob's been set up this whole time. Now, if we go ahead, and we just take our glass here. Let's go ahead. Make a little enclosing for us. Since I'm the scientist here, I know a ton of stuff. Do this. And we put this into a container, as it said. Now, with those mixed together, if we just close this container up so nothing leaks, go ahead, turn around, stay here, and let's see here. Seal. See? Turn around. Oh, look, it's caught fire. Isn't that cool? It stopped. Let's go see what we have in store. Okay. Look at that. We have salt. Table salt. That's kind of cool because we just had a reaction, right? We got a good old reaction from sodium and chlorine. Isn't that cool? Now. Oh, wait. Let's just take chlorine back because we need to put it back. We can't just leave this here. Anyways, Bob, we'll lead you to go ahead and clean up this mess. And then we have our salt here. We can go ahead. Just put this on the counter. Put our elements back. And that, we just witnessed a Ionic an ionic compound. Isn't that cool? Okay. Now that we have our salt here. Now we're just gonna take some chips. Yeah. You get a bit hungry on the job here. Yeah. Take some chips. We go ahead and we'll read about the next sentence. Put the chips and the salt over here. Anyways, now on to the next. Now you must be wondering, what are we moving on to? Molecular. That's what we're moving on to. When nonmetals combine, a pure substance called a molecule or a molecular compound is formed. Molecular compounds differ from ionic compounds in several ways. They can be solids, liquids, or gases at room temperature. They tend to be insulators or poor conductors of electricity. They also have relatively low melting and boiling points because of the forces between the molecule are weak. Examples of molecular compounds include sugar, however you say that, and water. Now, a great thing is here. If we just take, good old coffee. We have a coffee here, and I take a marshmallow. We got liquid marshmallow as well. If I take a marshmallow, you must be wondering, why do I have a marshmallow? If we were to take a coffee here, we just throw that marshmallow in. If you would actually notice in real life, the marshmallow would start melting as a whole, and this would be a simple molecular compound. Isn't that cool? We learned two things: ionic and molecular compounds. That was pretty easy, wasn't it? Now, once again, you're way smarter. You're way smarter this time. As you keep watching, you'll get more smarter. Let's go over to Bob and see what he thinks. Bob, what do you think? Yeah, see, they're doing pretty good at learning, aren't they, Bob? Yeah, I noticed that too. They're pretty smart, aren't they? Yeah, you get to cleaning up the mess over there, okay, Bob? Thank you, Bob. Have a nice day, Bob. See, Bob is a smart person. He's been in the lab for a while. He knows smart stuff. Anyways, have some fun. You learned some stuff. See you in the next video.